Okay, I got my audio recording now. So this one says that side lengths of triangle RST are given. Triangle RST is similar to triangle UWV, where S corresponds to V and T corresponds to W. What is the value of tan W? Well, this one's not too bad at all, actually. We do have to note a few things, though. If triangle RST is similar to UWV, I'm going to draw this out. So, like, let's say we have R. It's a right triangle, RST. So, it looks like from T to R is the longest legs. So that's going to actually be the hypotenuse. And then I'm going to assume it looks maybe something like this, RST. So starting at R, going through S, ending at T. From R to S is 20, from S to T is 48, and from T to R is 52. Then we know that this is similar to triangle UWV. So UVW, U, V, and W. And these are of course right triangles. And then we want to find out the tangent of angle W. Tan of W. So what is the tan of W? Tangent is going to be referring to opposite side over adjacent side. When we're looking at angle W, the opposite side is this UV, and the adjacent side is from V to W. And since these are similar triangles, we know that the side length ratios are going to be similar as well. So it's going to be the same side length ratios here, 20 over 48. The opposite side is 20 compared to the adjacent side of 48. That's of course not the answer choice, not in the answer choices, because we need to just simplify this a little bit more. But if you divide everything by 4, you would get 5 over 12. And that's the simplest form for tangent W. Any questions, feel free to let me know in the chat. I'm going to put in another question. For anybody taking an SAT tomorrow, good luck. I see we got some questions in the chat, so let me paste those in and we'll get to those right after this first question that we just did. Or after this next question, I mean. This next question, right triangles and trig, is saying triangle RST, point W not shown lies on RT. Somewhere, W is here somewhere. What is the value of cosine of RSW minus sine of WST? So cosine of this angle and sine of this angle. One thing that the SAT is testing you on is sines and cosines of complementary angles. So if you have two angles, one important rule to remember is that if you have two angles, like let's say A and B, and they add up to 90 degrees, then the sine of one of those angles is equal to the cosine of the other angle. So sine of this red angle and the cosine of the green angle should actually be equivalent to each other, because you can see that angle RSW and WST, those add up to 90 degrees. So they must be equal. So if cosine of RSW is equal to sine of WST, then that would just be 0. We're subtracting something that's equivalent to itself. So it's going to simplify down to 0. Okay, let's go into these questions. Let me paste a little bit higher quality. These look like from a Blue Book practice test. So This one is saying for the line H, the table shows 3 values of x and their corresponding values of y. Line K is a result of translating line H down 5 units in the xy plane. What is the x-intercept of line K? So this one, we're going to first find an equation of this line, and then we can translate it down by 5 and then solve for the x-intercept. So if you want to find the equation for this line, we could start by the slope. Slope will be pretty simple. We can take one of the y values minus another y value, and then subtract their corresponding x values as well. So I just took these first 2 points. So what's that? 30 over 5, so the slope is 6. So if we're starting to form an equation here, we could say like y equals mx plus b, where m, or the slope, is equal to 6, and b is equal to, well, I haven't found that yet. But if we wanted to find the slope, we could plug in a point into our equation. So for example, something like 130 is equal to 6 times 18 plus b. And then b would just be equal to 130 minus 6 times 18. 6 times 18 is 108. So 130 minus 108 is 22. So we have an equation. We have an equation that's going to be y equals 6x plus 22. And then we're also now going to be taking it down by 5 units. Down 5. Then that would just become 6x plus 17. And finally, if we want to solve the x-intercept, the x-intercept is going to be at the point where y equals 0. So 0 is equal to 6x plus 17. And so if we subtract 17 from both sides, we get negative 17 is equal to 6x, or we get x is equal to negative 17 over 6 once we divide that 6 through. Let's do the next problem that was submitted. This one says we have a system of equations, 2x plus 3y equals 7, and then we have 10x plus 15y equals 35. For each real number r, which of the following points lies on the graph of each equation in the xy plane for the given system? So one thing I noticed right away, I don't know if it'll be helpful or not, but this bottom equation is just 5 times whatever the, it's multiplied by 5 to get from the top equation to the bottom equation. So it looks like the same equation. And it looks like some of these are in the form where x is equal to r, and then the y value is something else. I might just check those points first because those would be pretty simple to check. If I plug in something like x equals to r, so let me try that in the first equation. If we set x equal to r, then we get 2r plus 3y equals 7. So 3y equals minus 2r plus 7, or y is equal to negative 2/3 r plus 7 over 3. So we have x is equal to r, and y is equal to negative 2/3 r plus 7/3. Where did I go wrong? Because it doesn't seem to match with any of these answer choices. Oh well. Well, we can just retry, or we can plug some of these answers back in and verify whether they work or not. So looking at something like choice D, if I plug in this as my y value, it doesn't really look like anything's going to cancel out. If I plug in this as my x value, this might be what we're looking at. instead of plugging in x equals r, maybe we want to plug in y equals r. So this didn't really lead us to the correct answer choice. So let's try y equals to r. That looks like it would be answer choice B. And I'm just kind of ruling them out in terms of complexity, so I really want to try A last. But if I try y equals r, then we get 2x plus 3r equals 7. We would get 2x is equal to negative 3r plus 7, or that x is equal to negative 3 over 2r plus 7 over 2. Actually, that looks like it works. Y equals to, if y equals to r, x would have to equal to this negative 3 halves r plus 7 over 2. And that matches up with answer choice B. And thankfully we didn't have to try A. A is just really, really complex. Let's do some more problems. I see we have some more submissions. These look like pretty much SAT style questions. And we have another one. So this is a quadratic equation. It says y equals a times x plus 6 times x minus 4. In the quadratic equation given, a is a non-zero constant and the vertex is located at point x comma y. What is the value of x? Okay, we're just solving for the vertex. Well, I know that the vertex is located halfway between the x-intercepts. So if we're looking at this structure of this function here, we have x-intercepts at the following points where x equals to negative 6 and x equals to 4. So if we take an average of those two, then the middle point between, this is 0, here is a 4, here's a negative 6. The middle point between negative 6 and 4 is going to be negative 1. So the parabola might look something like this. So the x-coordinate of the vertex, should be at negative 1. Is negative 1. That looks like answer choice D. Yeah, the SAT might ask you to do something like this. But you can also, if you have really no idea, you can also plot it out in Desmos. So something like a times x minus 6, or let's say y equals a x plus 6, x minus 4. You can put in whatever value for a, it doesn't really matter, because the vertex is going to be right here at negative 1. So let's move on to the next one. We have this equation, 1/2 root a is equal to 2 cube root b. A and b are positive real numbers. If a equals 8 and the equation is written in the form a to the power x is equal to b, what is the value of x? Well, they gave us a, so we can now use this first equation to solve for b. So if 1/2 square root of 8 is equal to 2 cube root of b, I can start to undo the operations on this b side to be able to solve this. What I'll say is, let's first start by dividing everything by 2, as that will get me 1 over 4 times the square root of 8 is equal to cube root of b. And then the next thing I can do is raise everything to the third power to cancel out the cube root. And that'll give me 1 over 4 cubed. I'm going to convert this 8 into fractional exponent. So to the power of 3 and is a square root, and that's equal to b. And then we want this, we want the equation to be written in this form: a to the power x is equal to b. So we want 8 to the power x is equal to b. So I want to convert this 4 cubed into some power of 8 as well. And I know that this is, first of all, I can write this as 4, or, well, 4 cubed is going to be 1 over 64. And then the next step that we can take is converting 64 back into a base of 8. That is 1 over 8 squared times 8 to the 3 halves equals b. And so last thing we need to do is we have 8 to the 3 halves on top. We have 8 to the 4 halves on the bottom. So we do 8 to the 3 halves. Let me write it explicitly like this to make it very clear that we are going to be now subtracting the exponents. So 8 to the negative 1 half is equal to b. If we match it up with the form that was given in the question, then x is equal to negative 1 half. Nice. That was a kind of a tricky exponent question, but looks good. Let's do a few more problems here. What other topics do we want to see? Let me look for some. There are some really tough questions in nonlinear functions. Okay, we maybe have a submission. Okay, I'll put in. This looks like maybe one we did for SAT question of the day. So this one is a reading question. It says, in 1943, in the midst of World War II, mathematics professor Grace Hopper was recruited by U.S. military to help the war effort by solving complex equations. Hopper's subsequent career would involve more than just blank, more than just equations, though. Looking at the answer choices here, more than just equations, though. As a pioneering computer programmer, Hopper would help usher in the digital age. So it seems like this sentence right here. So let's ignore the first one since that's not what's being tested. But the second sentence, Hopper's subsequent career would involve more than just equations, though. It seems like we want a complete sentence here. We want an independent clause here because that would express a complete thought. So we want an independent clause, and we want some kind of punctuation that can follow that independent clause. Because right here we have sort of like another clause. D has no punctuation at all. C has a full stop, but it puts the full stop in the wrong position. Hopper's subsequent career would involve more than just equations. Though, as a pioneering computer programmer, Hopper would help usher in the digital age. So the though should be kept with the equations. Like, though is signaling sort of a contrast. Hopper's subsequent career would involve more than just equations, though. So C puts the punctuation, the full stop in the wrong spot. And then B forms a run-on sentence because we introduced Hopper already, or her career, and we introduce Hopper again within the same sentence. That's what B is saying. So really we want A here. We have an independent clause followed by a colon, which is an appropriate use. And then we can add after the colon our clarifying information and elaborate upon what was just previously said. So it's kind of just standard grammar rules here. Okay, let's move on to the next questions. Staro's been submitting a lot of questions. Where are you getting these questions from? They look similar to like SAT, but a little bit harder. Okay, let's go through it. So if x is 2k% of y, what is the value of 3k% of 0.3y? That's just like extremely weird. But we can start by writing this into equation form. So x is means equals, and then 2k%. Well, if you think of k% or any percentage, like 50% is just 50 out of 100. K% would be k out of 100. And then 2k% would just be 2k out of 100. And of means multiply, so we're taking 2k out of 100 times y. Then what is the value of 3k%? 3k% of 0.3y. It's like extremely complex. But we can do this in a couple of ways. We can either take the first equation and solve for x, or you could try to modify this equation so that it fits this format right here. And that might almost be easier for me to do, is just to take, we can, in order to match this up, we can multiply by 0.3, right? So we get the y to turn into 0.3y. And we can also multiply by 3 over 2. So we can cancel out the 2 here and get a 3 up in the numerator to get this part. So really it's just going to be x times 0.3 times 1.5, which is 3 over 2. And 0.3 times 1.5 should be 0.45. So when we apply these changes, our x turns into 0.45x. So it looks like it should be answer choice C. These are a lot of good SAT questions. Anybody taking the SAT tomorrow or this week should be studying up for sure. Yeah, I'm going to be taking it this Saturday. Nah, we'll see. Do you get to take another redo after the senior year retake? I think you can take it anytime you want, as long as you sign up and you pay for it. Like College Board is like, okay, yeah, you paid for it. So let's go over the parking garage question. A parking garage charges $11 on weekdays and $15 on weekends. If the garage brought in $53,234 in 1 week, wow, and 4,122 people used the garage, how many people use the garage during the weekend? It's just a systems of equations problem. So what I would do is set up an equation like, let's call x the weekdays, and let's call y the weekends. And we're looking for the weekend, so we're going to be solving for y in particular. But let's say, or more like, more correct for us to say that this is the number of people who used it on the weekdays, and this is the number of people who used it on the weekends. So in total, number of people x plus y on the weekdays and weekends should add up to 4,122. And the total money that they made was $11 per person on the weekdays and $15 per person on the weekends, which brought in $53,234. I mean, you can solve this out by hand, but I wouldn't recommend it if you're taking digital SAT. I would plug it into Desmos and get x plus y equals 4122, and then we get 11x plus 15y equals 53,234. You're going to have to adjust your bounds quite a bit. I'm going to go between like 0 and 4,000 because we know total of 4,000 people use the garage. And it looks like my x coordinate is at x equals 2,149. 2,149. So this is the solution of the systems of equations. 1,973 people. How many people use the garage during the weekend is going to be, remember, the variable y. So we found the solution of the system. A system works when these x and y values are true. And so looking at the y, the number of people on the weekends, is going to give us answer choice B, that 1973. Let's keep on moving through the rest of these questions. I think we've got some good question submissions here. Yeah, you'll likely want to use Desmos for at least some of the questions. So this next question, the exponent question, it says a to the power of 2x cubed over a to the fourth is equal to a to the 12th. What is the value of 2 to the power x? Well, we can use the exponent rules here. So a to the power of 2x cubed over a to the fourth equals a to the 12th. That means we can first use the rule of subtracting exponents. If we have two bases, two of the same base, and we're dividing them, we can subtract the exponents. So our first step would be a to the 2x cubed minus 4 is equal to a to the 12th. And at this point, you can equate the exponents because we have one base on this side, one base on that side. Then we can equate the exponents to get 2x cubed minus 4 equals 12. So 2x cubed minus 4 equals 12. I'm probably just going to throw that into Desmos and see when does 2x cubed minus 4 equal to 12. And it's when x is equal to 2. X is equal to 2. So 2 to the power of x is going to be 2 squared equal to 4. And 4, not 2, but you would plug in 4 as your final answer. Okay. We got more problems here on circles. This one looks interesting. This circle problem is saying what is the length of the minor arc AB given the diameter of the circle is 12 and the measure of the angle of sector AOB is 72 degrees. They probably should have labeled the center here, but it's okay. So let's call this center O. What is the length of, basically they're asking for this arc length right here. given that the diameter of the circle is 12, so from here to here is 12 units, so the radius is 6, and the measure of this angle is 72 degrees. For this one, you might just need to remember the arc length formula. So if we're taking arc length formula, we have S is equal to x degrees out of 360 times 2 pi r. So really arc length is just a smaller portion of the circumference. So we take the circumference 2 pi r and we multiply it by x over 360. That's the proportion of the circle that we're currently taking up. So if we plug in those values, like 72 degrees and 2 pi r with r equals to 6, 2 pi times 6, then I'm going to also throw that into Desmos and get 72 over 360 times 2 pi times 6. Oh, well, they have their answers in pi, in terms of pi, so I'm just going to leave out the pi and see numerically what that computes to. It computes to 2.4, and then I'm going to throw the pi back in there, so 2.4 pi. It's a good equation to remember for sure, and I don't think it's actually on the reference sheet. We have another circle problem here, but it's circle equations instead of circle theorems. Well, both of them I guess are like circle equations, but this one is a geometric interpretation of a circle. Yeah, so it's asking what's the center of the circle given that equation is, let me plot it out here. X squared plus y squared minus 6x plus 4y equals 36. That looks really distorted. What did I do? I probably need to adjust my axes a little bit. That looks more like a circle. If I just visually check points like -3, 2, that is definitely not the center of the circle. If I check something like 2, -3, it's closer, but it's not the center. 3, -2. Oh, that one looks very, very close. And -2, 3, that one's very far away. So it looks like our actual center of the circle is going to be 3, -2, which would be answer choice C here. You could also solve this algebraically. Like what you can do is called completing the square. So let me show you guys what that looks like. So if you're completing the square, yeah, you would waste time on a SAT, potentially. Depends on how fast you type. If you're completing the square, I would group these different terms together, like x squared minus 6x, and I'm going to put a plus blank, and then plus y squared plus 4y plus blank equals 36. In order to complete the square, you need to take half of the coefficient on x. So -6, half of that is -3, and you need to square it. So I would add a plus 9 here. And then for this one, half of 4 is 2, and 2 squared is 4. And I also have to remember to add that to the right side as well. A couple things to explain here. Why did I do that? Well, now you can see that this here is perfectly factorable. Basically that's the formula for finding the constant term that you need to make this perfectly factorable, as this is going to be x minus 3 squared. This here is going to be y plus 2 squared. So by taking half of that coefficient, squaring it, and adding it, you make it perfectly factorable. And you just have to remember to add that number to both sides to maintain the balance of the equation. So we're not changing the value numerically, we're just changing it into a slightly different form that makes it easier for us to identify the center and the radius. So it's at 49. Now you just need to compare this to the standard form of a circle, which is x minus h squared plus y minus k squared equals r squared. So h comma k is your center, and r is your radius of the circle. And because they're asking specifically for the center of the circle, our h value is 3, h equals 3, and our k value is negative 2, right? Because it's y minus k. So assuming k is negative 2, that would make us y plus 2. So you can solve that algebraically. You could solve it with Desmos, and it's probably quicker to use Desmos depending on how fast you'll type. But yeah, let's move on to the next. Let's move on to our next question, which is a lot of circle questions today. Those tend to be some of the hardest. Okay. So, in the given circle, the radius is 6 centimeters. 6 centimeters. And the angle of angle AOB measures 7 pi over 12 radians. What is the value of the arc length AB? Well, there's another formula that I can mention here. Like the one I mentioned before was if you're dealing in degrees. In radians, the arc length formula is r theta in radians. Meaning if your angle is in radians, you just multiply the radius times the angle. Then S would be equal to 6 times 7 pi over 12, which is what? 6 over 12 is 1/2, so 7 pi over 2, which is answer choice A. If you didn't know that, you can also convert the radians into degrees if it's easier for you. So you could multiply by 180 degrees over pi. That would cancel out the radians and turn this into degrees. Okay. I see we got another question submission. This may be the last one just in the sake of time. But also, I don't see that this is really like an SAT style question. So let's see how far we can get. We have PQ is a chord of length 8, and the circle is radius 5. The tangents at P and Q intersect at a point T. Find the length of TP. Okay. Well, I know that I can draw another leg of the triangle here and get 5 centimeters as well. I'm not sure if that helps, but that gives us an isosceles triangle here. And then we're trying to find the length of TP. I don't know. Maybe I'm missing something. If you have a hint, I'll gladly take it. But I might need to think about this a little bit more. It's kind of outside the scope of the SAT. Okay. I see one more SAT question, so let's do that one first, and then we can come back to the previous question. So, oh, we pretty much filled out the whole list. So this SAT question says at the start of the winter, the US stockpile of corn was 5 billion bushels. 2 months later, P% of the stockpile had been used. So what represents the number in billions of bushels of corn remaining in the US stockpile at the end of those 2 months? So P% of the stockpile had been used. Remember, P is a percentage. So to convert that into a decimal, we'd have to take it divide by 100. And I'm looking at, so I'm eyeing answer choice B, and I'll explain why. But we started with 5 billion bushels. We used P%, which means there is a remaining 100 minus P%. If we're converting either of those into a decimal, then it's 100 minus P over 100. That is the remaining amount, or remaining fraction. So we multiply the remaining fraction times the initial amount times 100 minus P over 100, and we have a remaining fraction. Did I take tutoring or self-study? I self-studied using Khan Academy. Why is it not A? Well, the 2 is irrelevant here. I mean, you could have told me this was 11 months later, and it doesn't really matter because all that's we're looking at here is that P% has been used. 2 times 5 times that fraction is saying that twice the amount is remaining. But we're just looking at the base number and not the time frame. Back in this question, someone said, I'm not sure actually. Yeah, this question I'm not so sure on. I mean, I guess what you could do, yeah, no problem. You could set up a third, or another isosceles triangle here and here. And as long as you could figure out some of those angles, you could solve this out. So maybe let's try this. Yeah, thank you guys for showing up. So like this angle right here, I'm going to split this triangle in half. And what I'm dealing with here is 5, 4, oh, so 3, 4, 5 triangle. Okay. Well, the angle right here is going to be inverse sine of 3/5. So let me calculate that real quick. And I want to work in degrees, probably. So 36.87 degrees. Then to find the green angle, that's just 90 degrees, because the tangent forms a 90-degree angle, so 90 degrees minus 36.87 degrees. So that green angle is 90 minus 36.87 is 53.13 degrees. And so if we're taking let's see, we could split this in half as well and kind of deal with half the triangle again. So let's say like we have, this is 4, that's our right angle. This is TP, what we're actually interested in, and this angle is 53.13. So how can we do this? I may not have enough information. Oh no, maybe I do. because we can use law of sines here. So this angle is, this angle in red that I'm going to draw is 180 minus 90 minus 53.13, which I'm pretty sure is just that 36.87. So if we use sine of 36.87 over 4, that's the same as sine of, is this true? Sine of 90 over TP. So TP is equal to sine of 90 or times, let's say 4 times sine of 90 over sine of that 36.87. So what does that equal to? I think sine of 90 is just 1. And sine of 36.87 is, okay, so I get TP is equal to 6.67. I'm assuming with the rounding, it's going to be TP is equal to 6 2/3, which is 20 over 3. So if you've got the answer, feel free to throw it in the chat, but that's what I end up getting. Anyways, that's all the question. That's a full board right there. Make sure you guys check out my exploreadvancedtestprep.com page if you have any desire to see any more things like this. I record all these sessions and I post them. And yeah, definitely come back next week. We'll talk about how the SAT went and go over your questions. Okay, see you later.